All right, once again, good morning, good afternoon, good evening from anywhere you might be joining us from. My name is Oladapo Babalola, one of the co-founders of DevOps as a Service Nigeria, which is a mentorship platform in Nigeria to raise and train the next generation DevOps practitioners that will go out there to innovate and disrupt their spaces. And so the unique thing about daas.ng is that we're not just teaching what DevOps is, but we are teaching you how it works from the foundation to a certain level of understanding for everybody. And so DAS is free and will not request money from anybody. This is just our way of giving back to the community. Right. So on behalf of my co-founders, Nuruddin, Kamilu, and Oluwaseun Oyetoyinbo, I welcome everybody once again to this class for today. So today we're going to be talking about Kubernetes, right? And we won't waste any more time. We'll just jump straight into it. So please let me know when you can see my screen so I can commence. Okay, can you see my screen?
Yes, we can
Yeah,
see
we can
your
see it.
Hello?
Yes, we can see
Yes, we
your
can see your screen.
Okay. All right, I just wanted to confirm that you can see my screen. Sorry. Okay. Can you still see my screen? Can you confirm that I can still see my screen?
Yes.
Okay, yeah. So cool. So Kubernetes is an open source platform that automates Linux container operations, right? And so just a little bit of intro. Kubernetes was first developed by a team at Google, right? And was later donated to CNCF. So the meaning of CNCF is Cloud Native Computing Foundation. So Google has been using Kubernetes for a very long time, right? And out of their generosity, they decided to make it open source for everybody. And so what they did was to donate it to Cloud Native Computing Foundation, CNCF, which is an open source software foundation that promotes adoption of cloud native computing like Kubernetes. And they also hold, several conferences, several developer programs and conferences around the world. So thanks a lot to Google and thanks to CNCF for, promoting Kubernetes, for always updating and upgrading Kubernetes. So that is just a shout out, to the big minds that actually made Kubernetes, a very, very wonderful platform, right? So let us go straight in. Now, to better understand Kubernetes, don't allow anybody to fool you that Kubernetes is complex. If you want to believe it's complex, then it's going to be complex for you. But if you want to believe it's easy, then it's going to be completely easy for you. And the truth of the matter is that it's not everybody, it is not all organizations. In fact, most organizations, they only stop at the Docker level and make use of Docker Swarm, to be able to orchestrate their workloads. Some even stop at the level of Docker, because the truth of the matter is, if you don't understand the concept of Kubernetes, it's going to be very, very chaotic, especially if you are, running your workload in production. So not everybody uses Kubernetes. Not everybody understands Kubernetes, right? But what we are doing here, within DevOps as a Service Nigeria is to demystify that mindset that Kubernetes is complicated. And that's what we're going to be doing, today, and also in subsequent classes. So Kubernetes is going to be broken down into two. We will not finish everything today, right? It's going to be handled by myself and Nuruddin. So Nuruddin would, take the second class, but today there's going to be about introduction, straight to the point. We are not teaching anything complex. We're just trying as much as possible to break down the entire concept for you. So let's just go ahead. So when you hear Kubernetes, right, the first thing that should come to your mind is orchestration. And if you can see my screen, right, you can see that this is more like an orchestra. And in front of that orchestra, you can typically see someone that would actually call a conductor. So think of this conductor like the guy that would tell the members of the orchestra how many musical instruments that are actually needed for a concert. How many violins, how many drums, which ones to play, like who are the guys that would play the trumpet, who are the guys that would mount the violin, when they should play, how they should play, and including things around how loud each of them should be able to play, and so on and so forth. So you can see this guy as the conductor, right? You can see the guy as a conductor. So Kubernetes works that same way, right? So again, just like I've said, Kubernetes is an open source system for automating deployment, scaling, and management of containerized applications. This is very, very important. This is a very, very important definition. It's for what? Automating deployment, scaling, and management of containerized applications. So I will encourage you guys to watch this Kubernetes documentary on YouTube. I think I've already opened it here for you, right? So this is a Kubernetes documentary by some of the guys I actually follow every day. Like, I love these guys so much. Like, I follow them, I follow their blogs, I follow everything that they do. And these are the guys that actually created Kubernetes. Wonderful guys. So if you can just go to Google, type Kubernetes documentary, right? You see the likes, you would hear from the likes of Tim Hawking, Craig, Chris, Philip Heikais, and all. So they talked about how, in fact, they actually started from Docker. They talked about how Docker started to, all of the story into how Kubernetes was created. So these are like the guys that I think I've actually listened to this. I've actually watched this video like maybe more than 20 times, right? Just trying to just understand how they started Kubernetes, do you understand? So you can just watch the video, the mindsets, and what have you. All right, so that's that. So let's go ahead. So how did we get here in the first place? Why are we actually using Kubernetes? Why do we need a conductor? So first, we got here because we wanted our applications to run without any operating system, right? Remember the Docker class that we had a few weeks ago, where we drew this diagram. I think I should still have it here. Okay. Sorry, let me just copy. Okay, so remember that we actually do this diagram. Let me just move this down a bit. Remember that we drew this diagram during our last class, where we have a host, where we have this, right? And then we say that for us to be able to run containers, we need an infrastructure, which is usually like the base system that is needed. So we need an infrastructure. So this could be a bare metal server. So I'll just name it as S. We need a bare metal server. Then on that server, of course, we need to install an OS, an operating system. It could be Windows or it could be Linux. Then on top of this, we'll now install what we call a container engine. So this was what we did, during the Docker class. So we have a container engine over here, right? And then on top of these container engines, we can now deploy the different Docker containers, which we did, in our subsequent classes. Now, what is usually the content of this container? We have the applications, right? We have dependencies, we have libraries, we have what have you, right? So now, this is good, right? This is good. Our applications are running, the dependencies they need and what have you. Now, what if you now want to have multiple of this particular scenario? What if you now want to have another server, that has the OS, that has a container engine, and now want to deploy several containers? Let's say you want to have maybe like 20 of this. It's possible. It just means that you would have to log on to the server one after the other to maintain all of these Docker containers. If they go down, you will log in to bring them up. Do you understand? Now, this system, ideally, right, is manageable. You could actually do that by logging in every now and then. For example, let's say there's a monitoring in place that will tell you the number of containers that you have running. If anyone should go down, you have to log in manually to bring it up. So this is actually possible. But a better way to be able to do this is to now have another layer, something like this. Oh, sorry, is to now have another layer. So you can just like this, have another layer. So you can have other servers that, will still host the same workload, and then just install Kubernetes. So that Kubernetes will now help you to manage all of your servers in one pane of glass. So even if this Docker container goes down, you don't need to log on to the server to be able to bring this up, because of the intrinsic properties and characteristics of the Kubernetes. It's going to bring this container up automatically if it goes down. It can also help you to manage, resource allocation and what have you. Do you understand? So, so it is very, very important that we recruit somebody like this guy. So just imagine all of these members, all of these instrumentalists. You can just see them as containers. But you need someone to be able to, monitor all of these musicians, tell them when to play, tell them the kind of musical instruments to use, and what have you. So the same way is the same function that this conductor, the same functionality that is actually attributing here is what Kubernetes also does as well. So Kubernetes is the captain. It means here we need to recruit a captain or a conductor who can look after all the containers. And that captain, we can call that captain Kubernetes, because this Kubernetes or this man here is highly available and efficient. Now, a point to note is that we have other orchestration technologies like Docker Swarm, Mesh OS. So Mesh OS is spelled this way. So we have Docker Swarm. We have Mesh OS, right? So this guy is actually built by Apache, right? While Docker Swarm is built by Docker themselves. Then there's another one again built by Oracle. It's called OpenShift. So this is built by Oracle and all. So for Kubernetes, was built by Google, and it's now being managed by CN. It's now being managed by CNCF, right? And this is commonly used by virtually everybody, like virtually all of the organizations that you know today, right? Okay, so now going on, we'll now talk about the different architecture of the Kubernetes itself, like what comprises of the Kubernetes. Now, the first thing that you should note is that, so let me just clear this a little bit. So the first thing that you should note is that in Kubernetes, right, they will talk about different themes. So the first thing that you should note is what we call a node. Node. Oops, sorry, let me use. So we have what we call a node. So by the time you hear node, just know that they're talking about a server. So a node is just a server. You can just say a node as a server. So basically this is just a server which Kubernetes is going to run on, right? And it's used to be able to run containers and what have you. Now, the next terminology is a cluster. But before I talk about the cluster, right, under the node, we have two types. We have the master node and the worker node. Very, very important. So we have, under the node itself, we have the master node. Okay, let me just do this. So we have the master node and the worker node. So what is the function of the master node? The master node is the brain box of Kubernetes. It's as simple as that. It's the brain box of Kubernetes, and it manages the activities of the worker node. So let's say this is the master node, right? And then you now have several worker nodes. You have several worker nodes, right? So the master node is here, and then the worker nodes are here. So the master node is responsible for managing all activities happening on the worker node. It's as simple as that. Now, the collection of everything that we've drawn here is called a cluster. So a cluster is a collection of nodes that work hand in hand to be able to achieve redundancy. It's as simple as that. So these are basic interview questions that I'm just giving you. They will tell you that what are the different type of nodes that you have. Simple answer is master node, worker node. What are the different functions? Master node is the brain box of the Kubernetes cluster, and its primary function is to be able to manage the worker node, or some books would call it slave nodes, right? So that's that. So moving on, the master node that we have here. Remember, I said that the master node is more like the brain box of the entire Kubernetes cluster. So there are different entities. Let me not delete this. There are different entities that make up the master node. It is also noteworthy to understand that the master node can also be called the control plane. Control plane. So this can actually be used interchangeably, the master node or the control plane, right? And the control plane itself has some other moving parts that actually make up the control plane itself, right? So let's go ahead and now talk about the different components of the control plane itself. So this is what we have here, right? So this is the master node that you can see here. So this is the master node. Why these are the worker nodes, worker 1 and worker 2. So within the control plane, let's just quickly look at the function of this API server scheduler controller manager, and etc. Remember, this is just a server. On this server, once you install or bootstrap Kubernetes, it comes installed with all of these entities, which will just run through. Again, this is another typical interview question that you should know, and not just knowing alone for interview purpose, but you should also know the function of all of these components so that when something is wrong within your cluster, you would know that, oh, okay, my scheduler is not up. I need to go and check my scheduler, sort of. So the first one is the API server. Now, once you hear API, the first thing that comes to mind is communication, connection, right? That's the first thing that actually comes to mind. So the same is applicable to the API server. Now, the API server is the front-end connection to the Kubernetes cluster. So meaning anybody that will need to communicate with the control plane. Let's say there's a user that needs to administer the control plane, right? That user needs to communicate with the API server. It's as simple as that. Because this is the front end that handles connection to the Kubernetes cluster, and users interact with the entire cluster by making use of the API server. Second one is the scheduler, or something that is also known as kube scheduler. And the simple function of the scheduler is that it's its own responsibility. Sorry, does anybody want to ask any question?
Yes, sir. My question though, it's something that I have been struggling with for a long time.
Okay, so please just keep your questions. There will be time for questions so that we don't yeah, there'll be time for questions, right? So that we don't waste too much time on the call. All right, so the next one is the scheduler. Now, the scheduler is just used for distributing containers to the worker node. Its own function is, by the time you are ready to deploy your containers or to deploy what we call pod, which is we're going to talk about, this is the guy, the scheduler here, that is responsible for deploying the pods or deploying your applications to the worker node. That is just the function of the scheduler. The third one is the controller manager. What does it do? From the word controller, right? The way I don't cram all of these things, but the way I usually used to remember is that I know a controller general is more like someone in the military, right? And his function is just to watch other soldiers, just to ensure that, soldiers that are going for war or soldiers that are on duty are always, they are not sleeping. Do you understand? Like, they're always up and running, right? And if any soldier should go down, is the controller general's responsibility to be able to bring up that soldier, to remind that soldier the function of why he is, or like the purpose of why he is a soldier. So you can just see it like that as well, controller. So controller manager is the brain behind the orchestration. And what they do is that they watch to make sure that no container goes down. They watch to ensure that no container goes down. And if they do, this service, controller manager, is responsible for bringing the containers back up. It's as simple as that. So by the time you hear controller manager, remember the controller general is a soldier, always ensuring that soldiers are up and running. So if you try to deploy, let's say, your pod and it's not coming up, or you try to deploy your pod and nothing is coming up, it is likely that this controller manager is down. Do you understand? Now, the last one here is the etcd. Etcd is, you can just see it as your storage, right? It's called a distributed key value store. This is another typical interview question. They will ask you that name the entity within the Kubernetes cluster that is responsible for storage of information in a key value store manner. Simple, etcd. So etcd is a distributed key value store to store information in the cluster What kind of information does it store? Information like the node, within your Kubernetes cluster information, the actual and desired state of the cluster and what have you. Right now, all of these are like the different entities within the master node itself. So let's go to the worker node. Let us talk about the runtime, the container runtime. So remember, during our last class, we talked about the function of the container runtime. And the function is what? Is just to run containers. So you have your container runtime here. This could be Docker, this could be containerd, this could be cryo, and what have you. Do you understand? So, but in this case, right, you can use any container runtime. And the function is just to be able to run your containers. Now, kubelets. Kubelet is just an agent that runs on all worker node. And what do? They relay information to the master. So you can see the kubelet here. So you can just see the kubelet as the gossip person. The guy is just always communicating to the master node, telling the master node all the information about the worker node. So it relays information to the master and ensures that the containers are running, like all the containers are running as expected. So see this kubelet as an agent that runs on all of the worker node, right? Now, the kube proxy. By the time you hear proxy, what should come to your mind? Like the first thing that should come to your mind is networking, right? Telecom. So see this kube proxy as the telecommunication component of the worker node. And the basic function is to facilitate networking and ensure there is communication within the node and outside the node. So a common interview question is, they will ask you that, what makes up the Kubernetes master server? Then what are you going to mention? API server, scheduler, controller manager, etc. What makes up the worker? What are you going to mention? You mention kubelets, kube proxy, and container runtime. It's as simple as that. It is not complicated. Now, let us go to another concept called another entity. This entity here called kubectl. So kubectl is just the command line tool that you would always make use of to administer the entire Kubernetes cluster. So the same way we have Linux. Linux is just the command line interface to be able to administer your Linux server, right? kubectl as well. Kube control. Some would call it kube control. Others will call it kubectl. So kubectl is just that command line tool, which we're going to demonstrate shortly. It's just that command line tool that you would always make use of to be able to deploy application within your cluster. And any command that you need to type, that you need to, if you need to administer anything within the Kubernetes cluster, you will need to start with kubectl space, whatever it is that you want to type. It's as simple as that. So, setup of Kubernetes. I think within our Discord channel, I think for the last week or 2 weeks, I told you guys to be able to set up your cluster. So you could use Minikube. All right, you could use Minikube. So Minikube is just for testing purposes. So you could use this tool called Minikube. You can actually use it to try out Kubernetes locally on your PC. So you can see what is there. Minikube is a local Kubernetes focused on making it easy to learn and develop Kubernetes. So please don't attempt to use this for production. Don't even try it. This is just for your sandbox for testing purposes. You can also use a tool called Micro K8. Now, by the way, by the time you hear K8 this way, K8 is still the same thing as Kubernetes, right? K8, this K8 is still the same thing as Kubernetes. Now, what it just did was just to remove from U here, and then the they added SPN. So if you count this, 1, 2, 3, 4, 5, 6, 7, 8. So this 8 here, so this 8 alphabet represent this 8 over here. And of course, the K is still here, and then the S. So most times you hear K8, K8, K8. They're talking about Kubernetes. So there's a tool called Micro K8, which of course works like Minikube as well. You can also set up, Kubernetes using the Micro K8. You can see lightweight Kubernetes, pure upstream, blah, blah, blah. So you can just watch that video on how to be able to set up Kubernetes on your environment. Another one that you can make use of is what we call kubeadm. So kubeadm as well can be used to set up a Kubernetes cluster. And this can also be used on production. So you can actually use kubeadm as well to, be able to bootstrap your Kubernetes cluster and also run your production workload. Now, the last bit is you could also run Kubernetes on cloud, right? You can run your Kubernetes on cloud, and then the version of Kubernetes that on Azure is called AKS on Azure. So it's called Azure Kubernetes Service. Now, what this means is that you could run your Kubernetes on Azure, right? You don't need to worry about maintaining your control plane, because the bulk of the work is, as a DevOps practitioner, right? You need to always maintain this particular brain box. This brain box, by the time it goes down, then you're going to lose virtually all your data. And that is why it is important for you to carry out backup, replication, redundancy in place and all. Some will tell you that you shouldn't have only one control plane. Others will tell you that you should have redundancy for the control plane, so that if one control plane should go down, there is another, there are other control planes, that will step in. So you will need to, back up your etcd, back up your controller manager, back up, entire entities. You need to ensure that your control plane is up and running. So it's a whole lot of work for the DevOps practitioner if you are running this on-prem. But if you're in the cloud, Kubernetes is going to manage this control plane for you. So you don't even need to worry about the control plane, right? The only thing I just need to worry about is just the worker node. And as far as your worker node is up and running, right? As far as your control plane is up and running, your worker node definitely would still be up. But if one of the server goes down, right, the pods or the containers can actually move to another server. So AKS would help you to be able to manage all of that. Now, if you are able to know Kubernetes very well, right, the same knowledge of Kubernetes on-prem is still what you're going to use on Azure. There's no difference. So Kubernetes is Kubernetes anywhere. Do you understand? It's still the same language, it's still the same process. But of course, you still need to learn a few other things to be able to set up AKS. Another one is EKS, and this is the equivalent of AKS, but on what? On AWS, right? So it's still Kubernetes as well. They will tell you about how to be able to deploy your EKS and all. Then the equivalent of that on Google Cloud is called GKE, Google Kubernetes Engine. So they are all Kubernetes, but they are managed by different vendors, different organizations. All right. Then for this class, you could also make use of a tool called KillerCoder, killercoder.com. So it means if you just want to practice Kubernetes without installing anything, you can just go to killercoder.com and scroll down to Kubernetes here, or you can make use of any of these links here, CKS, CKA, CKAD. So this is more just like a sandbox, like a playground for you to be able to practice CKA. So if you click on anyone here, right, then click on playground here. So automatically you would have a playground. Do you understand? Where you can, practice Kubernetes. It's as simple as that. So you don't need to set up anything on your sandbox environment. Okay, all right. So moving on. So let's talk about pod.
Please,
Right?
sir, what
Let's
about
talk about pod.
cups?
What?
Cups.
Kops.
Yes.
KOPS. I think
Yes.
I think I've heard of kops before. That's why I say there are different Kubernetes way of bootstrapping. There are different ways of bootstrapping Kubernetes. So you could actually use kops as well. So, but again, you are not limited to one particular vendor. You can use any. The end game is that it's still the same Kubernetes. It's still the same structure. The commands are the same. So you won't say because you're on AKS, Kubernetes on AKS is different from Kubernetes on kops, or is different from Kubernetes on EKS. They are the same thing, the same control, like the same etcd controller manager, everything. Remember, I said that Kubernetes is open source. Because it's open source, it's still the same format anywhere. I can decide to come up with my own. I can call it DOPS, DOPS. I'm just is still the same Kubernetes. Do you understand? Okay, so let's go to pod, right? And this is where the main work starts. Now, a pod, remember when we started our Docker class, what do? We would always deploy our applications to run inside a container, right? Are you guys with me?
Yes.
Good. So we would always deploy our applications to run inside a container. Now, Kubernetes does not deploy containers directly on the node. Remember, Docker deploys containers directly on the node, but Kubernetes, it doesn't. But instead, the containers are encapsulated into a Kubernetes object that is called pod. So, common interview question that they would just want to see your composure. They can just tell you that a pod runs inside a container, true or false. Before you know it, you would have missed the response. Just know that a pod hosts containers. It's as simple as that. A pod does not run inside a container, but instead what? Containers runs inside what? Pod. So again, a pod is a single instance of an application and is the smallest object that you can create in Kubernetes, not container. So the smallest object, because a container is not an object in Kubernetes, but a pod is the smallest object that you can create in Kubernetes. This is another common interview questions. So for guys that have been asking about, okay, what are the interview questions? You recall that since when we started this bootcamp, we'll teach you the concepts and we'll also talk about common interview questions that you not even miss. They will ask you that what is the smallest object that you can create in Kubernetes? Some will say container. You've missed it. So the smallest object that you can create in Kubernetes is what we call pod. So if you need to scale, you don't need to deploy multiple containers in a pod, but instead you deploy multiple pods in a cluster. Do you understand? So having multiple containers in a pod is not best practice, right? But instead you should have, let's say you have different applications. Remember that during our first Docker class, we talked about Golang, how to be able to build an image for Golang. Then we talked about what? Node.js and Express app. We did for both. So if you need to run those two applications, you don't run them inside the same pod. So you run them per container. So this can be your Golang app running inside pod. This can be your what? Your Express node app running inside another pod. It's as simple as that. So there is also a concept of having multiple containers in a pod, just like we have here. Now, such containers so let's say that this container one is running the application itself, just like that's our Golang container. Why these other ones, they are called helper containers. They're called helper containers. And the reason why they are called helper containers is that they're just there to assist this particular container to perform some functions. They're called helper containers. But I'm not going to be talking about helper containers because it is actually beyond the scope of this class. But that's keeping everything simple. Okay, so moving on. So let's clean our board a bit. Okay, so moving on. How do we now create a pod? What do we need to do to be able to create a pod? And that is where the concept of YAML comes into play. I'm sure some of you would have heard of YAML. YAML. So YAML is used to represent configuration data. YAML is used to represent configuration data and usually defined by a key value pair notation. Do you understand? And they're actually used to represent structured data in a way that is easy for us to read and for machines to be able to read as well and generate whatever it is that you want to generate. So how do I create a pod? I make use of YAML. YAML is just a language for configuration. It's as simple as that. I need to create maybe a service within Kubernetes. I'll make use of what? YAML. And what is the meaning of YAML? YAML stands for yet another markup language, right? Or it has another name. YAML and markup language. It can be used interchangeably. Either you call it yet another markup language, or YAML and markup language. Do you understand? But the most important thing is that YAML is used to, for configuration purposes. And it's usually used in a key value pair. Now, what do I mean by key value? So let's just quickly look at an example of how to be able to create a YAML. So a YAML is just, remember the word key value. It means you must have a key and you must have a value. So let's create an example of a key value. So a key value can be name. Yes?
Yeah, I thought they also use a command to create a pod.
So when you say command, how do you mean?
Like just running, if you're running kubectl, get create or apply, then you now run a simple command like on terminal, then you deploy. You don't have to create. So now that's why I saw it somewhere like that, but I didn't
need to talk about imperative and real running. There is like when you declare or it does express it explicitly.
Yeah. So we'll talk about that. So we'll talk about the declarative and the imperative ways of creating objects, right? Okay, so but here, right, we just want to talk about how to be able to create basically we're just talking about YAML because you need to understand the YAML before we start creating the different objects that you know today. All right, so how do you create a key value? The first thing that you need to do is to define your key. So your key will always come before your value. So name is called key, and then I'll just put a semicolon this way. Apply a space and maybe type my name. It's as simple as this. Key and value. I could also type my states, or let me type maybe my best food. Maybe rice. Key, value, right? Now, when you now need to define multiple values under the same key, that is when we make use of what we call a list or an array. Very important. When you want to have multiple values, remember this is the key and this is the what value. So if you need to have multiple values under the same key, right, it is possible. By the time you start defining that, you are already defining what we call a list or an array. So let's say an example. So let's say team Docker. So within team Docker, right? So by the time you create the key this way, if you now want to create the values, just press your enter and tap your space key maybe like 2 or 3 times, but just try as much as possible to indent it. Please don't use your tab. Just tap your space bar. So I can just tap it 1, 2, 3 this way, right? And start with an hyphen this way, a space, and I'm putting the members of Team Docker. By the time you press enter, automatically it's going to indent you to tell you that you can follow the same indentation that has been created to add more values. So let's say under Team Docker, we have Dapo and we have Chain. This in itself is called a list or an array. So, and this dash, just like I've said, it indicates that this is an element or this is a member of that array. So if you now want to further create some attributes for this key, for this value Dapo, right? You can still do it. So let's say I'm trying to bring out Dapo and I want to create some attributes for this Dapo, meaning what are those properties that defines Dapo, right? So what I need to do is I need to press enter. Remember the space 1, 2, 3, right? Then I can now start talking about my complexion. I think I'm fair. Press enter. My height 6 feet. Press enter. My gender male. You see? So now by the time you extract, a particular value out from an existing key value notation, by the time you extract it out and then now start defining more characteristics about that value, then you have defined what we call a dictionary or a map. So this is a dictionary. Why? Why this is what an array? It's as simple as that. So just know all of these concepts so that once you start creating our pod manifest, right, you won't be confused. Okay, so the last bit is, let's now say we now want to combine these two together. What do we need to do? So this is what we just need to do. We would remember, so we'll just do this. Team Docker, right? So let me just remove this. Oh, okay, well, can still do it inside this guy. So Team Docker, right? I need to combine, how do I put it now? I need to combine these two together. A way I can do it is by defining, let's say, Team Container, right? Same way. Press enter. Right, my space bar, let's say 1, 2, 3. Define the name. Name is what? Dapo. Right. Define the state. State is, let's say, Oyo state. right? Once I'm done with this value, I can define another person's name here. So this is going to be what? Name. Let's say Jane, right? Press enter. I want state as well. I want state is, let's say, Edo State. Now, can you see what is happening here? It's telling me that sequence item without dash indicator, because it is seeing that this state, as a child of team container. But this state is not a child of team container. This state is a child of this second name here. So I need to properly indent it this way, and we are good. So what we've created here is what we call a list of dictionaries or a list of maps. Remember, this is called what? A list or an array. So, and that brings me to what we call a comment. So I can just add a comment here and say this is a list of array. Sorry, a list or array. Why this is called what? A dictionary. A dictionary or a map. Why the combination of these two is now what we call
list of
a what?
dictionary.
Exactly. Lists of dictionaries. Or you can just call it list of maps, either ways. So again, this is just a simple way to be able to define. So by the time you know all of these things this way, like how to be able to define a list of dictionaries, a dictionary or a map, then you should be good to go. You won't have issues with defining your pod attributes. It's very, very important. So by the time you are done defining all of these things, right? Now, you notice that when I did this, when I made a mistake, right, something is correcting me. And that's because I have the IntelliSense for YAML installed on my Visual Studio Code. Now, how do you install that? You just go to your extensions here and then search for YAML, YAML. There's a whole lot of YAML extensions that will come out. But this is one that is supported by Red Hat. You can see that it has a what is it called? A verification icon here, telling you that this is actually supported by Red Hat. So install it. After installing it, you click on it, right? You can see the verification, Red Hat. And you can see the number of people that have actually downloaded this since inception, 13 million people, right? So install it. After installation, click on this wheel icon here, right? Manage it, then go to extension settings this way. Right. By the time you go to extension settings, you click on edit in settings.json. Right. So on your own, you will not have this line 3. So what it does need to do is just to copy this line 3, which I'm going to post on this Zoom, comment section. So just add this to it. After adding it, save it, close your Visual Studio Code and reopen. Automatically, you will have YAML installed on your IDE, and then it can always correct you the same way it is correcting me this way. So let me just copy this. So make sure that you have this exactly within your team. So I'll just paste it there. Right. So after doing that, save this, save your IDE, and then reopen it again for you to be able to apply. So let's go back. So you can see, because of what I've installed, it is correcting me. Another thing I can do is to copy this old stuff here and go to an online tool that can also help me to verify that my YAML is correct, that my YAML, file is correct. So I'll just minimize this. So you go to yamlchecker.com, yamlchecker.com, and then post and then paste what you've copied. So you can see immediately it is telling me that and I think there's a mistake somewhere. Okay, let me remove the comments. So here it's telling me that there is end of stream of a document is expecting whatever. So this, so if I remove this, let me see. Okay. So it is still because of the formatting I used. Because of the formatting I used, right? It seems some sort of indentation has been wrong. That was when I actually pasted it initially. It was complaining about this was this way, right? So because of this indentation, it was now seeing this Dapo as a child of Team Docker. So what I did was just to remove this space, right? And remember this issue that we're having is seeing that this state that we have here is a child of team container, but it's not a direct child of team container, but instead it's a child of name. So I'll just have to indent it this way, and then it will tell you that this is a valid YAML. Do you understand? If I should just intentionally make a mistake this way, can you see? It will tell me line what? It's telling me that line 15, between line 14 and line 15, something is wrong there. And you can just, correct it. So this is another valid syntax validator that you can also use as well. Okay, so let's go to a pod. So please, this is very, very important because I actually needed to, clarify this with you so that once we start defining our pod, you will know that, oh, okay, yeah, this is a list. Oh, okay, if you want to define a dictionary, then it has to be this way. Okay, this is list of dictionaries. Okay, yeah, I understand. Do you understand? So that we're not just typing stuffs here and you will now be confused or cramming. Again, you don't need to cram. I think when Nuruddin or Shion, they were talking during their last, when they held their sessions, they made mention something about what? Documentation. So please, documentation is key. You are not too big or too old to make use of documentation. Very, very important, right? I have my Kubernetes documentation somewhere. Sorry, where is this? So I have my Kubernetes documentation. Can you see? I have several documentations that I use. Like, I'm not a genius that I will now say that I know everything. So make documentation your friend. You don't need to cram anything. Very important. So let's also go and create a pod. So what do we need to create a pod? So I'll just delete all of this.
Please, before you move on.
No.
Hello, can you hear me?
Yeah. Yes, please go ahead.
Yeah, thank you. Please, the setting. I think I missed something. Though I've installed it, but I can't see that that settings. How you got to this? Please,
Okay, let me just do it again. So you go to extension. Where is it? Extensions. You've installed YAML, right? Have you installed this?
Yes, I've done that.
Okay. You click on this wheel icon.
Yes, I did.
Then click on extension settings.
Extension settings, yes.
Then click on this edit in settings adjacent.
Okay. It wasn't like, okay, click, let me see, it wasn't like this. Mine was very short.
Okay, so what do you have in your own? But do you have this? The most important thing is that do you have this block? Do you have this block in your own? So you don't need, because I've actually implemented some other things, not necessarily for Kubernetes, right? You won't see this in your own. This is just a custom stuff that I was doing for Bitbucket pipelines, right? But in your own, you might not see something like this, I guess, in your own. You might not see something like this. Can you see something like this in your own?
Yeah, I can see that.
Exactly.
But
So you
the
just
other,
need to
this Explorer, the other stuffs were not there. Just only the YAML, the schemas.
exactly. So
That's
you don't really need all of this information that you have here.
okay.
Just because I'll be able
Okay.
to, because I work with this tool a lot.
Okay.
Actually make use of Ansible and some other things, Python and what have you. So you might not really see
Okay.
this in your own, but you should see this. Oh, sorry. So you should see this, and what you just need to do is just to type in this line 3. That's all.
Yeah. Okay. Okay.
But
Thanks.
remove the comma. I already have a comma
The
here
comma.
because I have
Yeah.
another
Yeah.
thing
I'll remove
here.
it.
Yeah. Okay.
Yeah.
All right.
I
Yeah.
get it.
Cool.
Thanks.
Okay. So
Question.
okay. Let's ask our questions. I think we can ask our questions now. Please go ahead.
Okay, thanks to us for. Okay, before we dive deeper into various components of Kubernetes, I have a question regarding the architecture setup.
The
So
what?
in the architecture setup, like a setup of a Kubernetes cluster.
Okay. Yeah.
So in an on-prem enterprise environment, whereby we have things like a production data center and a disaster recovery data center,
Yep.
you want to migrate some of your application workload or like to deploy them in a Kubernetes environment.
Okay.
So this now is how will I be able to set up the architect such that there is always that production leg and a disaster recovery leg of it. Having in mind that in every setup, I think there's always one particular master node or what we call a control plane. So I want to achieve a high availability whereby if anything should happen to my production data center, I have the disaster recovery environment for me to fall back on. So how can I set up a Kubernetes environment that can help me achieve such? Is it
Good
something
question.
possible?
Yeah. Very, very good and important question. So there are different ways you can actually set up high availability. You recall that when I was talking initially, I said that you can have multiple control planes. So the multiple control planes is saying that you can have let's say maybe 3 control planes, right? Acting as what? Active. Meaning whatever it is that you have here is being replicated almost in real time to the other control plane. So you can have this within your primary data center and then deploy the second control plane in your disaster recovery. Do you understand? So that even if your primary data center goes down, the pod definitely, they know that you have 3 or more control planes. They will go and search for the second control plane. And of course, everything will still go on as expected. It's going to be business as usual. Do you understand? So what that means is that when you are setting up Kubernetes, right, there's what we call initialization. There's what we call kube init. So kube init is saying that you want to bootstrap your control plane. By the time you bootstrap your control plane, after a successful bootstrap of the control plane itself, right, there's going to be another message that will tell you that use this command, paste it on the worker node. By the time you paste that command on the worker node is going to join the control plane automatically. But before doing that, if you need to have multiple control planes, there's another command again. I don't want to go into installation of kubeadm, but by the time you go through installation of kubeadm, there are 2 types of commands that will be dropped for you. The first command is the command. The command that's going to be dropped for you is a command for telling your worker node to be able to join the cluster. And that second command is the second server that you want to act as the second control plane. You see that same command over there, right? So by the time you run that command, it is going to bootstrap a second control plane. So wherever that server is, if that server is on your disaster recovery data center, right? By the time you paste that command there, just ensure that at least there is network connectivity between your production data center and the disaster recovery. By the time you place that command, it is going to look for this master, and it would also become a master as well. Do you understand? I think when I was bootstrapping Kubernetes this morning, let me see.
Please, sir, can you just share a link for that, a video for us to watch?
Yeah, I will do that. I think when I was bootstrapping this, because I actually did this yesterday, and there are two commands, that would help you to do that. So let me just see. Say setting up Cube ADM. Okay, so let me see. I just want to show you the command so at least you can see an example of what I'm saying. Okay, so these are the processes of setting up Kubernetes.
Is it a with network, sir? With a network command?
No. I'm looking for so I'll drop this link. So this first one here, Cube ADM join, is telling you that you can join any number of worker node by running this command. So this was the first command I was talking about. Then the second command, I think they have extracted it out here. Let me see another link. Immediately after this instruction, there's another command underneath. Let me see this link, if it has that. So that at least I can show you. Let me see. You should know. This guy is blowing out everything. Let me see another link. But I'm going to drop a link for you now so that you can. It's just a second command. How to be able to set up another control plane is what I'm looking for.
Okay. So, but in this case now, let's say I have down the two controls plane, one in my primary and second one in the disaster recovery. So if I want to join a node, maybe that of an application that is on my disaster recovery center, like maybe VM now in disaster recovery, I want to make it a worker node. Am I going to join it to the control plane in the DR center or the one that is in the production data center?
No, you can join it to anyone. You can join it to anyone.
Okay, so if both of them are like
Do you
active,
understand? You can join to anyone. Yes.
So if both
yes.
control plane are active, is there where I can figure for all sessions to be going to the primary data center?
So again, you now the way it works is that the kind of load balancing in terms of informational traffic that happens between control plane is what is the name now? Is it by I have to look for the kind of load balancing that happens. But whatever it is, whatever communication that happens on one control plane, right? Remember that information needs to be saved inside the etcd. Immediately, that etcd is replicated to your DR site automatically. So even if your control plane on your primary site goes down, because you have the updated information of what has happened within the etcd of your DR, right? Everything will still work as expected. Do you understand? So, but it is recommended that if you need to join a new worker node to the cluster, right? Just point it to the primary control plane. I've tried this thing before and of course it has worked for me. In fact, I think I had like almost 5 control planes, and I could join a worker node by pointing it to any of the control planes that we have already. So it doesn't really matter. So it is not seeing it from the perspective of, okay, there's one at a disaster recovery site, there's one, on a primary data center anywhere. It's just that, is there any control plane that I can interface with to join the cluster? It's as simple as that. Do you understand?
Yeah, that's clear. I think where we need your help more is the area of the load balancing that happens.
Yeah, I would have to look for the, what's it called? I have to look. There's a kind of load balancing. I can't remember the terminology, that is being used. But the kind of load balancing that happens is that whatever information that has been saved within the etcd is replicated almost immediately. So far, there is no network lag. You can also configure your replication window. For example, if you don't want all your worker nodes to always communicate with other control planes, right? You can also specify that by saying that I want all my worker nodes to be able to communicate with the primary control plane and not communicate with any other control plane. But if within a specified amount of time, if they cannot reach the control plane, right, the worker node will not go down. The worker node will still be handling traffic. But guess what will happen? Nobody will be able to monitor the port. Scheduling will not happen. If that port should go down, there's nobody that is going to bring them up, because guess what? The kube scheduler that is responsible for doing that is also down. So there are different fault tolerance configurations that you can actually do, which is way beyond the scope of this class, right? By the time you do CKA, right, Certified Kubernetes Administrator, they would kind of like show you all of those principles involved. Now, after you have done that, there's another configuration that says that if the worker node cannot reach the primary control plane, it should switch automatically to it checks a list to see the other control planes that are within the cluster, and then it just routes its traffic to that control plane, and everything will still happen. So that is active on the control plane level. Active on the control plane level, but active passive on the control plane worker node level. So you can set active for both control plane and the worker nodes, right? And then active between the two control plane, as well as active passive for the worker node and then the secondary control planes. Do you understand?
Yeah, I get the logic.
Yeah, so let me just show. I'm looking for that command. I still ran it yesterday. So this one now, by the time you finally initialize your control plane, you can see what is here. Your Kubernetes control plane has initialized successfully. It's telling you to do this. Then it will now tell you that you can join any number of worker nodes by running each of these commands. So it's this command that you now paste on the server that is going to act as a worker node. There's another command after this one. That second command is the command that you are going to paste on what? They are going to paste on the server that's going to act as a control plane. Do you understand?
Yes, I get that.
Yeah, let me see if I can fetch an example of that command for you. Just 1 minute. I'm checking my archives to see if I have an example. Just a minute. Let's see. I don't think I have it, but I will look for the link. Setting up to we have to run VDM on Ubuntu. So you can listen to this guy, Just Me an Open Source, right? Once you go to Google, just search for Just Me an Open Source. This guy explained the concept perfectly. In fact, I think you can just listen to this guy. He has all of what is needed there, right? Then you can also listen to this guy as well. DevOps Cube. Those are the guys I follow. DevOps Cube, yeah, this guy here as well, right? So these two guys, I recommend DevOps Cube and Just Me an Open Source. Okay, so cool. So let's go back to where we were. Yeah, so let's go back. So how do we create a pod? Are you guys still with me?
Yes, sir.
Okay, all right.
Yes, we are.
So how do we create a pod? Now, just like I've said, you don't need to cram anything, right? You can create a pod by defining the different components needed within the pod. And the first one is what we call API version. Right now, because of the IntelliSense that I have installed, by the time I type API version, it is intelligent to know that that I'm trying to, start. Remember when we started by creating a Docker image, we started using the from keyword, right? The same process is going to also happen here. Right? If you need to start creating any objects. So an example of an object is a pod, is a service, replica set, which as we're going to talk about. If you need to create any object within Kubernetes, you must start with this API version. So I will just tab it. I'll just press on tab for it to be able to complete this for me. Now, what does this API version do? It tells Kubernetes, how to be able to interpret the rest of all the other commands that I'm going to type here. It's as simple as that. It tells Kubernetes, or it makes Kubernetes to understand how to interpret the other commands that we type here. Now, after the API version, right, there are different versions for different objects. So again, you don't need to cram it. What you just need to do is just go to what Kubernetes documentation, say file for Kubernetes, right? So just click on this, and this is just an example. So this is Kubernetes documentation. So don't do anything outside of here. Make Kubernetes your friend. So V1 is the version of the pod that we have as at now, right? The API version. So by the time you type V1, Kubernetes will know how to be able to interpret the remaining definition that we have here. So let's go back to the Visual Studio Code. So I'll just type V1 here, right? Press enter. Second thing, I need to define what we call a kind. So as I'm typing this, the IntelliSense is giving me that, okay, you want to define a kind, just tab it. And the kind, you can see the different kinds that we have. So the kinds are the different objects. So they tell Kubernetes the kind of Kubernetes objects that you are trying to deploy. So here, you can see the different objects. There's daemon set, there's deployment replica sets, which we'll still talk about, but we won't finish all of this. So what am I trying to do? I'm trying to define a pod. So I'll just type pod. Simple as that. Next one, metadata. Tab it again. You can see that it has given me what? Can anybody tell me what is happening here within the YAML? So what kind of representation is this? Anybody?
I think it's dictionary.
Good. Dictionary. So what will now happen is that it is based on the intelligence that I have installed here. This section is used to provide the metadata or information about this pod. And it includes things like the name, the label, and what annotation. So let's go. Type the name, autocomplete it. So the name, we can name this, let's say my pod, right? By the time you press enter, see what will happen. It will indent it under the name itself. So what is the next thing that we need to type? Labels. So again, you don't need to, so please can you mute if you're not talking? So you don't need to cram all of these things. Remember to always come to Kubernetes here and you can copy all of this if you need it, and then edit whatever it is I need to edit. So, right. But because I've been using this, I know all of the sequence involved. Now, the name, my pod, labels. By the time I pressed enter, automatically it is telling me that this is another dictionary under labels. And I'm going to tell you the function of the label. So under label, I can give another key value, let's say app, and I call this maybe login service, which I'm going to discuss what this means, right? So I press enter, and then I'm done under the metadata. So the next thing I need to define, I've defined API version, kind, metadata. The next thing I need to define is what we call a spec. So by the time you type spec and then you click on tab for the YAML intelligence to be able to complete it for you, see what is going to happen. Automatically, it told me that under spec, I must have containers. Another containers, I must have a name. Do you guys understand? So can you guys tell me an example of what this is? Anybody?
Array list.
Are you sure?
Yes.
What? Hello? Is anybody saying anything? So what is an example of this?
List.
A list of maps.
Exactly. List of maps or list of dictionaries. So that was why we did that first YAML illustration, just to tell you, what this does. Right. So let's go on. Now, under the spec, it's telling me that now this definition defines the specification or the desired state of the pod. So spec here is just to tell you that, okay, you have defined your API version 1, the kind is pod, the metadata. All of this is just still useless if I don't define the desired state of the pod. Now, what is usually under the desired state? For me to be able to define the desired state of this particular pod, I need to specify what we call a spec block. Under the spec block, that is when I will now start defining the container itself. Remember, this is a pod definition. Inside the pod definition is where you have container. That is why we need to define container on that spec. I'm not coming here to define pod. Nope. I'm coming here to define containers. So what is the name of the container that I want to give it? You can still give it the same name of your pod, which I'm going to do. Let's say let us say my container, right? The next thing is image. Define your image. So what is the name of the image that I want to give this? Let's say we want to give it Nginx image, right? Last one is ports, right? Tab it again. It is going to bring out the container port automatically. So let's say we want to give this container port 80 or port 8080. Now, what does this mean? Let me now explain. Metadata is the information about this port. This is just information purpose. Everything under metadata is just for information purpose, to be able to describe or identify, this pod itself. So the name of the pod is what? My pod. Labels. Now, we use labels when it comes to grouping. So let's say if you have 50 pods that are meant for, let's say you have 50 pods or 50 applications that are meant for front end, and you have another 50 for back end. What are you going to do? You are going to define 50 ports, right, for front end, define another 50 ports for back end. By the time you deploy it, it is usually very difficult for you to now start looking for the port that is doing front end or the port that is doing back end. These labels here would help you when it comes to grouping, so that once you are now trying to look for a particular port, you can now select or filter by this app login service. So it's going to bring out all of the ports that are for, front end. So I can just change it to front end for simplicity's sake, front end. So maybe I'm trying to get the port. By the time I put this filter, it's going to bring out all of the ports that are for front end. That is just the function of these labels, basically for grouping and filtering. The spec is to define the desired state of the pod. What is the desired state? The desired state is that I want to have a container running. The container should be able to make use of this image. It should be able to make use of these ports here. Question: what is the difference between these ports that we have here and these container ports? Now, this port here is just telling the pod that whatever traffic that is coming into this front-end application called my container, or let's even change this name to, let's say, Dapo application. So just make it uniform. So the name of the pod can still be the name of the container itself. It's saying that whatever traffic that is coming into this Dapo application, right, the ports that this particular pod is going to be listening on is what? Port 8080. That is what this container port is. Like, it's just simple container ports. By the time you hover on it, what is it telling you? The number of ports to expose on the port IP address. This was the value between blah, 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 blah. Remember when we held our Docker class, right? This here, this Golang app that we did here. Remember that we exposed port 8080 within the application. So you won't just come here and say, I want to just expose any port. It will not work. And that was why we started our Docker class, so that we can explain and show you guys how the ports are actually exposed within the application. You now have to work with your developer to understand what port he exposed within the application. Do you understand? Even for the Node Express app, remember that this was our the app.js. This was the port that we exposed during our second class. So that same port is what is going to be here. Container ports is going to be, so whatever it is that you have exposed in your application is what is going to be here. It's as simple as what? As ABC. So this image can now be the image that you have built. So if you have pushed it to a particular Docker repository, right, you need to come here and specify it. So during our last class, I think we pushed to, let me see, Docker Hub, I guess. Let me see. Docker container registry. Nope, is it this? Let me sign into my Docker account and show you an image that we pushed. Okay. So we pushed this 14 days ago. This was during our Golang class. So let's use this image and see. Right. So this is the name of the image and this is the tag. So if I need to use this, again, this is public view, meaning anybody in the world can pull this image, right? Because it's public. So let's use that same guy here. So we use this instead of using Nginx. Yes?
Sorry, I need some clarity.
Okay.
So, like, let's say in my Docker file, when I was building the image, I defined an external port for where the container should be listing on. So now, in my pod file, can I decide to maybe use a different port? Just like the way I can use a different port in my Docker file from the application defined port itself.
Good. So don't get it complicated, right? So let me just explain this again. When we're doing the Docker class the last time, right? Remember, we did two things. The application itself, this is external, right? And this is what? Internal. When we run our Docker run, the name of the container, and then we specify the -p flag to be able to expose an external and an internal port. The internal port here, let's say, is port 8080. So this internal port here was the one that was defined within the application, was the one that the developer, specified within the application itself. Whatever it is that I want to use as an external port, right, is I can use any port. I can use 1 million. I can use port 1 million here. I can use port 7070 here. It doesn't really matter, right? This is for Docker container. Do you understand? This is for Docker container. But within the Kubernetes pod manifest file that we're defining, whatever it is that you're defining inside that manifest file is not this. It is this same internal one. So please don't confuse yourself. It's the same internal one that you are defining here. If you come here and define port 5000, it will not, or port, or whatever port it is that is not inside the original application, it will not work. And that was why we started this class from Docker, so that you guys can actually understand where we're coming from. So this container port is a port that has been defined internally within the application. Is what the application would expose. So we have crossed how many layers now? 2 layers. The first layer was when we were doing this. The first layer was when we wrote this application, we defined port 8080. The second layer was when we defined the Docker file. Remember, we also exposed what? Port 8080. This was when we're creating an image. And then we pushed this image to what? Docker Hub. The final lap will now be when we now want to run it within your Kubernetes. We now come here and define that same port. And this is where people tend to miss it because they get confused that, well, what port am I putting here? Do you understand? So this port is a port that you have defined from where we're coming from. Do you understand?
Yeah, I understand that. Yes.
Okay. All right, good. Now, Emmanuel has a question that how can we run different objects? He said that we can use a command, maybe kubectl run, whatever it is that we. So that is good, but it is not advisable to run your Kubernetes object. Now, we need to run this pod. How do we run the pod? It's simple. We'll copy this, go to the Kubernetes cluster. So I have a Kubernetes cluster here. I can create a file. Let me call it pod.yaml and paste that here, right? I'll save it. And this is where we'll now start using kubectl. Remember the command line that I talked about, kubectl. So kubectl is a command that follows that after you type your kubectl, the next thing that follows is a verb, meaning you are typing Kubernetes to do something. So an example is what? kubectl get, because get is a verb, kubectl create, kubectl apply, kubectl list, kubectl watch. Anything that must follow a kubectl command must be a verb. Very important. So I need to create a pod, right? Because right now I can only do kubectl get. What do I want to get? Let's say I want to get the node within this cluster. Can you see? It is telling me that I have what? I have a control plane, which is a master node, and it's ready. And the name of the control plane is sandbox. This is the version, and the age is 12 hours ago. So if I need to add worker node to this particular control plane, right? It's simple. What I just need to do is to generate the join command from this control plane. By the time I generate the join command, I can now go and type it, apply it on any server that can reach this other server on the network level. So by the time I just type that, by the time I just paste that command there, I don't want to do that because it's going to expose my certificates. And of course, this is going on YouTube, right? And I don't want to be posting any sensitive items on YouTube. So by the time I generate the join command from here, you see my certificates, you see all the information, that are needed to be able to join this cluster. And if I run the kubectl get node again this way, right, you see another server. You see the status. The role you're going to see is none, and then the age and version. So you see none there. So none there means that it does not have the control plane role. It is just a worker node. It's just a slave. Right. So let's run this pod. How do we run this pod? Right, kubectl, right? Create, right? I want to create the pod from this file that I just defined here. I will now say, okay, create this pod from this file, -f. And what is the name of the file? pod.yaml. So by the time I create this, so what does it tell me? It's telling me that the pod called Dapo application has been created. How do I view it? Remember, kubectl verb. I want to get the pod that has been created. So kubectl get what? Pod. Can you see? I just created it. And what is the status? It is running. So meaning this application is running and it has not restarted. So how do I check the property of what I just deployed? kubectl is your friend. kubectl describe. You can see that all the commands that follow kubectl are all verbs. So kubectl describe. I want to describe a pod. What is the name of the pod? Dapo application. By the time you press enter this way, it is now describing the pod. So let us scroll up and see what is there. So we are describing this pod. The namespace is default. We'll talk about namespace shortly. It's talking about the node where this has been deployed. You can see the labels that we created. App front end, annotations known, status is running, IP address, So now, by the time we'll talk about networking shortly, but by the time you run any pod, right, automatically, Kubernetes assigns an IP address to it. Question now is, how do you get this particular IP address? The way you get the particular IP address is when you are initializing your control plane. Again, when you are on AKS, EKS, you don't even need to worry about the networking. You don't need to worry about so many things. But if you're going to be doing this on your end, you're going to be doing this on your server within your production data center and your DR sites. You need to give it a subnet. So when I was creating this, I said, Mr. Control Plane, as I'm creating you, make use of this particular subnet, 10.244.0.0 subnet. And that is like a /16 subnet, if I'm not mistaken. So what this means is that the subnet that you're going to give to your control plane must be a subnet that is not used within your network. So you can decide to say that control plane, see, make use of the subnet 17.17.0.0. All the IPs that will now be given to your containers will now be 17.17. Whatever, maybe .30, just the way you are saying it. So by the time you get to networking, talk about this. So this is the IP, this is the container ID. Now, remember I talked about container engine. This is it here. Meaning here, I am making use of what? Container D. If I was making use of cryo, CRI-O, you will see the cryo here. So this is the image that I defined, right? Okay, we're not using the Babalola 05 image again. Well, we'll still use this. So this is the image. This is the image ID. This is the port that we defined. The state is running. The ready is true, right? And of course, we have volumes which Nodun will talk about, during the next Kubernetes class, and some other things around tolerations, node selectors, and what have you. So if you want to look at the life cycle, look at the life cycle here. Said successfully. So can you see the guy that scheduled the pod? It's called default scheduler. And this is just your scheduler, your kube scheduler. So it was one that scheduled this pod. Now, what did he do? He successfully assigned this to the sandbox. Can you see that it was one that said that, okay, I need to deploy this pod. I need to assign it to someone. So he assigned it to sandbox. He assigned it to the control plane, right? He now saw that within the manifest file that we created here, it needs to pull this particular image. So whatever it is that has been defined here, the kube scheduler, the kubelets. So you can see all of the functions. The kubelet will be the one to pull that image. So it has successfully pulled this image. It has created the container DAPO application and it has started it. Can you guys see my screen, or I should increase it a bit? Is the font okay?
Yeah, the font is okay.
Okay. So
can you increase it a little, please?
Okay, let me increase it a bit. Can I increase this thing again? Please just give me a few minutes. Okay, view. Okay, yeah. Is this fine now? I should increase it again.
I think it's better now.
All right. So please, whatever it is they are doing, right, always be inquisitive. Check, be like me. Always be inquisitive. I'm not always in a haste to just jump on new technology. I want to be inquisitive. How did they even start? Like, what is inside container D? Right. I was close to creating my own container runtime. I was very, very close because I was very inquisitive about what is inside this container D. So be inquisitive. Do you understand? And I'm sure that very soon I would work on, I'm just trying to improve my Golang. I'll work on creating my own container, my container runtime. Sorry, yeah, my container runtime as well. And I'll just make it open source so that guys will start using that container runtime as well. That's the next project I'm going to work on. So, yeah, so that's that for creating a pod. Okay, now, so let's clear this screen and talk about what we call a namespace. Okay, so before we talk about the namespace, let us take a few minutes, maybe like 2 minutes to just stretch. If anybody wants to take water, we can just take water and we'll be back by 1:52. So you're back by 152.
Hello, Twe. Can anyone hear me?
Oh, yeah,
Ah,
yeah, yeah.
oh, okay,
Yeah.
okay.
Yeah, I can hear you.
Okay, yep. So let's continue. Please just give me 1 minute. Okay, all right. So let's go on. So let's go on and talk about. So hope we are all clear with kubectl, the pod that we just created. Are we all clear? kubectl gets pod. So I don't like to always type kubectl every time, right? So I can create an alias. An alias is just a shortcut, but please be very, very careful with aliases. As a DevOps practitioner, you need to ensure that you don't like the kind of aliases that you have on your servers are not disruptive. So alias is just a shortcut. And an example is saying I don't want to always type kubectl, but I want to type k. So I can create an alias by just typing alias. I want to create a shortcut and define this as just what kubectl. By the time you press enter, it means I can always do this k get pod. You understand? It's still the same way. So instead of always typing kubectl, you can just type k get pod. It's as simple as that. So your alias, please be very careful because you can type your alias as k, as maybe like m is equals to remove maybe your root directory. Like this is very, very dangerous because by the time you just go and type m, you have destroyed your server. So be very careful with alias. Always use it when you are in total control, just to make your work easier. Now, let's go to namespaces very, very fast. So would be very fast in these other subsequent topics. So let's go to namespaces. Now, what are namespaces? Namespaces are just a way to isolate your cluster resources, a way to divide your cluster resources between multiple users. Now, what does that mean? Let's say within this particular cluster, right, you want to run both your production and your tests workloads, though it's not best practice, right? Or let's say you want to run your staging, that's your pre-prod, and your tests containers, within the same cluster. It is possible. It is possible. What you just need to do is just to create a namespace. So a namespace is going to isolate your resources. So let's say in a cluster, you are running, just like I've said, you are running production and your test workload. You can create a namespace for this and the entire resource quota to say the test cluster must not use more than 5 CPU cores and let's say 16 gig RAM, while production is not limited in any way. To be able to do that, you need to create a namespace. So how do we create a namespace? Very simple. K, remember that K is what? kubectl, right? Before we create the namespace, let us get existing namespaces. K gets namespaces. Or just type namespace. You can also type namespaces. Anyone. Or you can do K gets ns. Do you understand? NS is namespaces or namespace. By the time you type this as well, it will give you all of the namespace that you have here. Do you see? So these are the default namespaces that came with Kubernetes when they were set up. So please don't mess with any of these namespaces. It is very, very important. Now, if you don't have any namespace defined within your pod manifest, because you see that within this pod manifest here, there's no namespace that has been defined. We just deployed it. By default, it's going to deploy to what? The default namespace. So by default, presently here, we're on the default namespace. So that's why I can do my k get pod this way. And this is going to tell me that I'm in what? The default namespace. So how do we do that? How do we check? So k, remember the word describe. I want to describe my pod, then type the name of the pod there.
So, can't you do it in the, like, if you create a namespace, like, let me see dev and
We're
pod
coming there. We're coming there.
I mean for the care, like the kubectl, when you actually run the command alias and stuff like that.
I don't understand what you said.
Like you're using care in place of kubectl.
Yep.
So can you also do that with namespace?
Can I also
Or
do that
just
for? Okay, so the alias, just like I said, is that you need to be careful on how you just create aliases. I already created one alias because I don't want to be typing kubectl every now and then. So I can just do my K, right? And I know that it is just what kubectl. And after that K, I can type any of the commands. I don't need to do alias for so many things. Do you understand? I cannot do this because I know that kubectl get pod would get my pod, right? I cannot do this. I can't create an alias, though it's possible, but it doesn't make sense to say maybe I want to call this kget, right? Is equals to kubectl get pod this way. Is this what you're saying? Like
oh
this?
yeah, it seems you don't really understand my question. What I'm trying to say is that you created this alias in the default namespace, right? And I'm asking if you can
It
also
can be
create.
used anywhere. It can be used on any namespace. So this alias is just a Linux command. It is not a Kubernetes command. Do you understand? The alias is just a shortcut that can be used with, on any user. But if I should log out and log in again, that alias will be lost because it works with sessions.
Okay.
Do you understand? Yeah. So it's just to make my work easier. Right, Emmanuel? I don't want to be typing kubectl every now and then. Like, I'm very lazy when it comes to typing repetitive commands. Do you understand? That's just that's the way I work. So you just can, if you want to be typing it full, you can, of course, you can go ahead, right?
All right. No,
So
Sorry,
we're describing this. Yes, please go ahead.
sorry, just for confirmation, like you just confirmed, if you leave the session and the alias is going to go, so like in Linux, if you want the alias to remain, I know that they go to bash rc to actually put this. So in Kubernetes, is there a configuration file to also have that, or it's not
It's the same
actually?
thing.
Okay,
It's the
thank
same
you.
thing. So just go to your I think it's, let me say, cats. No, sorry, cats. Bash RC. No, I'm not getting it. Bash. Yeah. So here, so you can just. So let's even do that. So let's nano the bash RC part here, and just add an alias. So I can just add it here, alias. Okay. So the same command, you can just add it here as well, kubectl. And by the time you exit, press yes, right? By the time you do this, you need to do what we call a source. So this is just Linux commands. So source is saying that I have created an alias by writing it in this bash rc file that is used for aliases. So any alias that you want to do, you can save it inside this part, this bash rc part, any alias. By the time you do that, you need to sort of apply it. So the command to apply whatever it is that you have done is just by typing source and pasting the path to the alias. And if you should log out and log in again, your alias would remain. So this question is, so this response is actually for Emmanuel, right? But again, this is not necessary. This is not Kubernetes. This is not Kubernetes scenario. This is just a Linux command to be able to help us, save aliases, so that once I log out and log in again, it should still be good to go. So K gets pod, so we are still good. So I was going to describe this so that we can see that the namespace is what default, at least by default, the namespace that is going to be specified if you don't define any namespace is what the default. Okay, so that's just everything about namespaces. So let us k get our pod again and delete this. K deletes pod and just delete this here. Okay. So this is going to delete the pod. So let us go back to our manifest file. So the pod definition that we have here is called a manifest file, a pod manifest file. So let us now say that we want this particular pod to be defined within a namespace. So let's create a namespace here. Remember, we are creating the namespace for what? Isolation. Right. So how do we create the namespace? It's just kubectl here, which is k. K creates what do I want to create? Namespace. What do I want to call it? Let's say daas. What can we even call it? Let us call it daas. So by the time you create this, k gets namespace again. You can see the daas. So I need to now deploy this particular pod within the daas namespace. Now it is going to come under the metadata. So I can, just after the name, I can define namespace here and call it daas. Do you understand? So, so what I just need to do is to copy all of this, come back to here, create another file. Now let's say pod, call it pod namespace.yaml, right? And paste whatever it is that you need to paste here. Save it. And we deploy k create -f and then create that the pod. So let's do something. Remember that we're still within our default namespace. So if we do k get pod, we shouldn't see anything here. It is telling us that no resources found in the default namespace. But we just deploy something here and it showed us created. Right. So it means that that pod is inside the daas namespace. How do we now get it? Right. We would still do our kget and define that I should get the pod, get all the pods in the in the daas namespace. How do we do that? You just append this, append the namespace and the name of the namespace this way. It's going to show you that application within the daas namespace, or you can still do it this way by just putting one hyphen and then n the same way. So kget pod will not give me any pod within the default namespace because I don't have any pod there, but I need to specify the location where to be able to get this pod, which is in the in the daas namespace. And that is what I have running here. Do we all understand how to do this now? Do we understand? Hello, are you guys still with me?
Yes.
Yes.
Okay. All right. So moving on. Okay. So moving on, right? So we are going deep, but we're going to make it very, very simple. Now, look at what is going to happen here. If I imagine I am running this application on production and someone just goes ahead to delete this k deletes pod. What pod do I want to delete? I want to delete this DAPO application. If I should do this, right, it will tell me that DAPO application not found, but I need to specify the namespace by just typing this, appending this. So it's going to delete it. And if I do my kgets pod again in the daas namespace here, it is gone. But there is a component in Kubernetes that ensures that I have a specified number of pod, of a specified number of pod running at every particular given time. So even if I should delete this pod 1 million times, right? The scheduler would always make sure that what I've actually defined in the definition file would, it would ensure that that number of pod is still running at every particular point in time. Now, what that means is that if I need this application, if I need it to have maybe like 5 instances running, maybe for load balancing at every particular point in time, if I delete 5, another 5 is going to be created. If I delete 3, right, another new 3 will be created. Now, what helps us to be able to do that is what we call a replica set. So a replica set ensures that a specified number of pod replicas are running at every particular given time. Now, how do we do that? I won't type that. I will just go to the Kubernetes documentation and just copy. Yeah, okay. So this is an example of a replica set here. Now, what do we have here? We have what the API version, we have the kind, just the same way that we did the pod. So let's just copy this, take it to, I'll just create a demarcation and paste this here. Now, we need this pod to be running 3 replicas, or let's change it to 4 replicas at every particular point in time. How do we do that? Remember the API version, it defines the it defines the version that Kubernetes is going to make use of for all of these entities that we have here. And the version is apps/v1. It is not v1. So that is why we have different versions. And that is why you must always, keep yourself up to date with Kubernetes documentation to understand the kind of API version here. What is the kind? The kind is not pod, the kind is what? Replica sets. Metadata, the name. So let's give it this same metadata name. Now, the labels. So we'll just use the same label that we use for our pod. I'll remove this. I'll remove this CL bit. The spec. Now, the only difference between the pod and the replica set is that we now have what we call the replicas and the template block. Aside from this, you would see that there's no difference between a pod and a replica. So the only thing that they've added is just what? The replica and the templates. What is the function of this replica? The function of a replica, you can see it here, is the number of desired replicas. This is a pointer to distinguish between this and this. This is just telling you that this pod, right, will have 4 of these pods running within the cluster by the time I create this replica. The selector. Now, the selector houses the match labels. What is the function of the match label? It is a label for determining which existing pod that this replica should control. So let's say that before now, right, we ran this pod, maybe we ran 5 of it and it's running. Nothing is controlling this pod here, because by the time we delete this pod, it is going to be deleted. But if you now want to make use of the replica set to control the existing pods, this is where you will now come and define it. You are defining it as, I am now the new boss in town and I want to control existing pods. How do I know the existing pods? By just pointing to their labels. That is why we are matching the labels, which is why you can see match labels here. And then we are pointing towards the label. So, which is what we're going to do here. That is the function of match label. That is another typical interview question. What is the function of the match label under the selector within a replica set? They've asked me this question before. Now, there's another one that is called the template. The template is the it houses the container name and the container image that is going to be created when you run the replica set. And you would notice that this spec that we have here, right, has now been brought in under the template here. You can see that the spec that we have here is now under this particular template. So if I run this replica set, it will make use of everything under the template segment to run these replicas. That is what this template does. It will make use of this and also make use of its own label. So this label is now the label that will now be assigned to the replicas that will be created by this replica set. So please don't get yourself confused. The match labels is for existing pod that's been in the cluster before the replica set was created. So by the time we put the label under the match label here, that's the label of existing pod under the match label, automatically the replica set is going to be king over them. That's why we are matching all their labels under these match labels here. These other labels that is under the template is saying that if the replica set now needs to create its own pod, if it needs to create its own replica, right, this is the label that is going to give it. That is what we have under the template label. So I'll just copy this same one and paste it here. So we can use the same nginx image name. So name can still be that application here. And the image is still nginx. This way, right? So we can even go and deploy and specify our ports the same way we have for this and this. So if you are able to get these concepts, you'll be good to go. So let us now deploy this replica set. So we'll copy this as well. And we'll nano it, we'll call it replica, maybe new replica set.yaml this way. We'll paste this, right? We'll save it. And k creates -f. And this. So it has created the replica set. What has it created? It has created the replica set. Now, if I now do my k get pod, can you see what is happening? It is running 4 instances. So let's do the same thing that we did. K deletes that pod. K deletes pod. Let's just delete one of them and see what will happen. It has deleted, right? So if I do my k get pod again, can you see what is happening? The one I deleted, it has brought up another one 6 seconds ago. So you can see the difference between replica sets and pods. So I can list the replica set I just created by just typing k get replica set this way. And we'll see that what the desired is 4, the current is 4, and the ready is 4. So I can also do k get rs this way. It will list it. Now, if I need to scale this replica set from 4 to 3, how do I do that? We can do it in 2 ways. For example, if you are running this on production and maybe the CTO has said that please kindly scale this up from 4 to 6. It's very simple. 2 ways that we can do it is by editing the YAML file that we created for the replica sets, which is, where is it? This. By editing it and changing it to 6, right? I'll save this. And so what will happen if I now want to remember that the pods are running, the replica sets are running. If I now want to apply what I've done. Like right now, k get pod is still 4. I need to apply it. I will not use create again. I will not use kubectl create again, but I'm going to use kubectl apply -f, point it to this, and you can see what has happened. Replica set configured. Just discard this warning. Then if I should now do k get pod again, can you see how many that is running now? 1, 2, 3, 4, 5, 6. Another way to be able to scale the number of replicas is by using what we call a declarative format. So there's a difference between imperative and declarative, right? Imperative is saying that if you need, let's say, Kubernetes to be able to create something, right? You would go ahead and tell Kubernetes all of the processes it must take to create that thing. Why declarative is just tell Kubernetes the desired results. This is what I want, get it done. That is just the difference between imperative and declarative. So we are going to use a declarative way here to be able to scale down this application that we have. Do you understand? I am not telling Kubernetes how to do it. I'm just telling Kubernetes, please scale this particular replica from 6 back to 4. That is declarative. But imperative is saying, I am telling Kubernetes, these are the process it will take you to be able to scale it. Do this, do this, do this, do this, and do this. So this is a typical interview question. What is the difference between imperative and declarative commands? So let's use a declarative way now to be able to scale down this application. How do we do it? Is what? K scale, right? You now assign the replicas. You want to scale it from 6 to 3, right? You now point to your replica set that we have here, which is here. K get replica set, which is what we have here. So you would point to the name here and inform Kubernetes that what you are scaling is an object called replica set. So K, we are scaling the replica to 3. What kind of replica are we scaling? We are scaling the DAPO application replica, and then we are putting the type of objects in front of it. So by the time I press enter this way, it has scaled. So K get pod. Can you see that it has scaled it to 3? Can you see what is happening? Are you guys with me?
Yes, sir.
Or we're confused? Are we confused? Okay, yeah, good. So now this is just a typical, I can't see the last command you are typing. Okay, let me clear this.
We can't see your last.
Okay, so this was the last command I typed. K scale replicas is equal to 3. You define the replica set and the name of the replica set that you've created. Remember, to get the replica set is just what? Type rs, which is replica set, or type replica set in full this way. You will get the name of the replica set. And to scale it, this is just the command. K scale, you can scale this. Let's even scale it as high as 10. K scale the replicas from 3 to 10, right? What is the name of the replica set? DAPO application. And what kind of object replica set? So by the time I do enter this way, and I do K get pod, how many pod do you have running here? 10. If I do K get pod again, you can see 10. If I want to scale it down, same command. Let me scale it down to 2 this time around. It's scaled. K gets pod. It's terminating. You can see that it is terminating, you know, the the numbers that have been defined to terminate, sort of. So the ones that are going to remain are just 2, and it's now terminating 8. So let me clear my screen and do k gets pod again this way. You can see that it is now 2. So now this is a very, very cool implementation, but you will not use this directly on production. And that is where the concept of deployment comes into play. Yes.
Hello.
Please. Yes.
Yeah. Thank you. I want to ask, would there be some form of auto scaling? I believe you would not, I don't know, you would not always go and scale manually the way you're doing this. Or I don't know, maybe there's something you can say about that.
Okay, so for auto scaling, right? That is an advanced concept, and that comes into saying that you want to scale when there's a response to traffic, or when there's a response to maintenance. Now, response to traffic is saying that automatically you have defined some scaling constraints, which of course is actually beyond the scope of this class. You are defining to say that if there is, for example, now I love money points a lot. I love what they are doing, right? And let's say their workloads, of course, are on the cloud. I don't know, maybe it's AWS, GCP, or Azure, right? Their workloads that actually handle POS traffic, right, on the cloud. And these are just different applications that have been defined within the Kubernetes cluster itself. You can see that during peak period, by the time we have maybe a surge in traffic, automatically we need the pod that is responsible for processing POS transaction to scale from maybe 50 to 70. It's going to do that automatically because it is responding to what? It is responding to the traffic load coming in. Again, that is an advanced concept, but it is possible. Secondly, you are saying that during off-peak period, maybe like from 8 to 9, when people are not making as much transactions as expected, by the time the traffic that is coming in, that has been coming in within the last 30 minutes is below 30%, scale down my pod to maybe from that 70 to maybe 20, it is going to do that automatically. That is response to workloads. Do you understand? And that can also assist you to reduce your infrastructure costs, because there's something we'll call CPU request and limits, which I don't know if we're still going to talk about it here, where you can actually define that this pod that is running, you need it because this pod is just like a server that you are giving CPU and RAM, right? They are using CPU and RAM. You will now have to define that, say, look, this is the highest that this particular pod here can go. The highest it can use is 1 CPU and maybe one CPU core and 1 gig of RAM. If it goes beyond that, Kubernetes is going to throttle it. Throttling means that it's going to kill the application, and another one is going to restart again automatically. Do you understand? So those are just part of the concepts that is the power of Kubernetes. So does that answer your question, Ido?
Yes, it does. It does.
Okay, cool. So quickly, let's just go to deployments. Now, you will not interact with replica set directly as a DevOps practitioner. You won't do that, right? What is going to help you to be able to interact with replica set is what we call deployments. So deployment offer more advanced features for managing application updates, rollbacks, and scaling. Replica set only manages scaling. Very important. Like all of these things are just typical interview questions. And that is why most of the tutorials that you see on YouTube, they won't give you the difference. They just tell you that this is how you deploy deployment. This is what it does. What are the differences? That is what you need to understand. The difference between a replica set and a deployment is that a replica set only handles scaling. It doesn't handle rollbacks and application updates. It doesn't handle that. But what handles that bit is what we call the deployments. So coming to this diagram that we have here, right? The deployment is always top level. A deployment would encapsulate a replica set, and the replica set would encapsulate the pod. That's the way it runs. So whatever it is that you need to do, always make use of deployment, because by the time you make use of deployment, it's going to, automatically include replica sets and all of its properties. So let's say there's a new update that has been done to the image on the repository, and this needs to be deployed to update the ports. Then deployment can help you achieve this. Now, there's what we call rolling updates. Rolling updates allows deployment update to take place with zero downtime by incrementally updating pod instances with the new one. What that means is that within this Kubernetes cluster, right, if there's an update that needs to be done to this particular guy, remember that the image that we're running is what? Nginx. If we need to change that image to this custom image that we have here, right? By the time we modify the manifest file, Kubernetes is going to do the deployment in a way that if users are still consuming this particular application, right, the users will not even know that there has been any deployment, like there has been any deployments done already, because it's going to do what we call rolling updates. Rolling updates is that it's going to, first and foremost, deploy one pod, ensure that it is running, and delete this old one. So meaning at that particular instance, we have one new pod and one old one running. It will now deploy the second new pod, ensure that it's running, and then delete the old one. That is what we call rolling updates. That's what we call rolling updates. Do you understand? So, interview questions, they will ask you that what are the two types of deployment strategies? The two types are rolling updates, which I've just explained, and then the other one is what? Recreate method. Recreate method is saying that it is also going to delete these two. It will delete these two at that particular instant and then create another two. That is the recreate, because it's recreating it. It's going to delete these two and then recreate two other. It can be faster, but what if a user is actually performing a transaction at a particular instance, and then you now go and do recreate method, and you just cut off that user's session and create another one? Of course, the user is not going to be happy with such customer. So by default, Kubernetes makes use of what? Rolling updates. So let's see how deployment is done. It's so simple. It's just for you to change this from replica sets to deployment. That's all. That is everything that I just need to do. Those are all the differences between a deployment and a replica set. So let us still copy this. Let us copy this. But instead of doing this, right, let us make use of that our Golang image instead of using Nginx. So remember, this is our Golang image that we pushed to the repository here. So this is the image and this is the tag, Babalola 05/test version 1. So that is what is going to be here. So this is going to be Babular 05 tests version 1. So it's still that application. The port that we used for that Golang application was what port? Let me see. Internal port 8080 good. So we'll still leave it as port 8080. The app is front end to replicas. Okay, 4. Right. So let us deploy this. But before then, K gets replica set to delete it. So K deletes replica sets. What are we deleting here? Okay, so this has been deleted. So we'll go ahead and copy these are deployments. Nano deployments.yaml and paste this here. So do yes and k apply. So you can either use create or use apply. Any of it will work. So let's use k kubectl apply -f and the deployments. So these have been created k get pod. So can you see what is happening? Remember that we deployed the what? We deployed the deployments. So automatically from this our diagram that we drew here, the deployment should automatically create a replica set. So let us check. So k gets replica set. Can you see? It has created that replica set. We did not do this manually, but deployment was able to do that. So how do we also get the deployment? K gets deployment, or you can just shorten it to deploy. K get deploy. This is the name of the deployments. So if you now want to, get the pod, okay, I think we've gotten the pod, k get pod. So you can see the 4 that was deployed by what? Replica sets. That is what we have here. So it's being managed by this replica set. And this deployment is the one that is managing this replica set. So deployment managing this replica set. This replica set managing all of these pods that are here. So I can now do my rolling update itself. Okay, so lastly, let's quickly talk about networking, because as this thing is running like this, right? There's no how we can have any form of traffic coming into it. So Kubernetes does not include any built-in networking solution out of the box. So everything that we've been doing here by default, if you deploy this on your environment, right, Kubernetes does not include any form of networking by default. But if you're on cloud, it comes natively with networking. So, but because Kubernetes does not have any networking solution, for third parties, and it doesn't have any networking solution. That is why we, as the DevOps, practitioners, we need to install the different third parties that actually support Kubernetes. And then an example is what we call Flannel. There's Flannel, there's Calico, there's Weave, there's Cilium. So if you should come online and type Flannel kits, right? It's going to like give you the basic info about Flannel. Can you see Flannel runs a small, allocating a subnet of list to each host, blah, blah, blah. So Flannel enables networking in Kubernetes, right? And is a third-party tool, which you must install when you are installing your Kubernetes. So if I do k get pod in all namespace, right? So this is the command to be able to get all of the pod in all my namespace. By the time I press enter, you can see my pods that are default within the default namespace. You can see a kube Flannel here, which is also running as a pod. And this is what enables networking. So there are different types. There's Flannel, there's Calico, there's Weave, and there's Cilium. Like there are a whole lot of other things. Now, what happens after you have actually deployed your pods, and these are like different servers, so to say. So what happens is that if you should, so this is, let's say this is server 1 and this is server 2. If you just have container D running, container D is a container runtime, it's just a container runtime, right? That enables you to be able to run containers. By the time you do this and if this server 1 and server 2 are not part of the Kubernetes cluster, there might be conflicts because there's what we call the container runtime networking interface itself called Docker 0. So is this Docker 0 that will assign IPs to the different containers automatically? So if I should start a new container, remember this is not running on Kubernetes. If I should start a new container, this Docker 0 is going to assign IPs to container 1 and container 2, right? This host or this server as well, it is possible that this same container 0 is assigning almost the same IP to container 1 and container 2. So it means if there will be any form of inter-host communication, there might be conflicts because you are having two containers with the same IP. And that is where the concept of container network interface come into play. So it's saying that you will now have like an interface that these guys would connect to, right? They will connect to what we call a CNI, container network interface, that will now assign them unique IP addresses or unique subnets or IP addresses. By the time you have this in place, then it means that these containers that you have here, there won't be any form of conflict because you have like a central CNI they are connecting to. And this CNI is container network interface. An example is what? Calico, Flannel, Weave, or what? Or Cilium. Very, very important. Now, by the time you do that, see what will now happen. It means by the time you join these two nodes to a particular Kubernetes cluster, right? This is now going to act as the what? As how do I put it now? This is going to act
Gateway.
as a gateway, exactly, as a gateway. And then you have the CNIs. So this is a CNI in this particular cluster. This is another CNI. So there can never be any form of conflict. So when it now comes to assigning IP addresses to the pod, right, you can see that, let me increase this a bit for you so that at least you can see it well. So you can see that the IP address of the pod is what? 10.244.1.2, 10.244.1.3. What do we now have here on the second server? We have what? 10.244.2.0. So that is where this CNI comes into play, right? So let's quickly move on so that we'll now talk about how to be able to expose our pod. Now, how do we now direct traffic outside of the cluster? How do we allow users to be able to connect to this, our application, to this, our pods that are running? It's very simple. And that is where the concept of services come into play. So a service is what facilitates communication between different objects within the cluster.
Lisa, I have.
Okay, please ask your question.
Yeah, this is where I have problem. Like in terms of when I'm installing the Kubernetes, like the production Kubernetes. After installation, I'll run the Weave network and a controller manager will be failing. Then sometimes it will be still working. Sometimes the API, no, not the API itself, the how do I call it? Scheduler will be failing too. So what is the real cause of that? Because I don't
So the root
understand
cause
why.
of that, is compatibility. So that is why you mustn't just be focused on just one kind of CNI. So if Weave is failing, remove Weave, install Flannel. If Flannel is failing, remove that, install Calico. If Calico is failing, remove that, install Cilium. So you can try the 4 of course, definitely one will work. So this same issue that you have, I'd also encountered it, before now, I was making use of weave. So weave is not usually stable, so to say. That was why I now switched to Flannel. And then if you can see my cluster here that I created, you can see that this is Flannel and it has not restarted. So this Flannel is the one that handles networking. If I should delete this Flannel, right, completely, another one is going to be recreated automatically. But during that period, there won't be intercommunication between ports and services. So this Flannel that you are seeing here is the one that is responsible for networking. So if it's weave that I want to make use of weave. If you install it, you're going to see cube-weave, and then you see the pod running. But please don't mess around with anything that is within your cube system. Again, don't mess around with it. Your core DNS here, although I've not talked about core DNS here is used for DNS, domain name resolution, so that you are now able to call the ports directly with their names and not with the IP addresses. Do you understand? So let's rush now. So we need to direct traffic into our cluster. Now, by default, this is the pod. So just see this pod as this particular guy that is running here, right? You can see this pod as this that is here. Automatically, an IP has been assigned 10.244.0.2. Let us see the IP address of this particular pod. How do we do that? Let me clear my screen and do k-get pod again. So k-describe, I want to check the details of this pod by describing the pod. So k-describe pod, put the pod name here and press enter. So can you see the IP address that it gave to the pod? 10.244.0.6, which is the same thing as what you have here, 10.244.0.2. Do you understand? Now, this is the CNI that is responsible for assigning the different IP to the different ports, right? How do I now connect traffic so that guys outside can now be able to call the application here? Do you understand? That is where the concept of a service comes into play. So a service, so we need to deploy a service and inform that service that whenever you are running, expose this particular pod to the external world so that users can now connect to this cluster and then call the application. Do you understand? So there are different types of services. There's cluster IP, there's node port, and there's load balancer. So cluster IP by default only handles, so if you have pod here, you have another pod, you have another pod. Cluster IP only handles in intra-cluster communication. That is where cluster IP comes in. So you define a service called cluster IP to handle intra-cluster communication. Now, that is what the cluster IP does. If you now want to do inter-cluster communication, that is communication from outside of this particular cluster, that is where you now use node port or you make use of load balancer. So node port assists. So by the time you deploy node port by default, it does the inter and intra together. But cluster IP only does intra, that is within. But node port does intra and inter. So let us now define a node port and see what happens when we define a node port. Now, this particular server itself, this server, it has an IP address. The IP address is 192.168.1.1.1, which is this here. If I should clear this and get the IP address of this server, IP add and more it. So this is the IP address of my server, 10.3.4.42, which is something like this as well. So this is the IP address of the server, right? Now, users can be able to reach, if I deploy a particular service not running as a container on this particular server, and that service is running on port 2020, right? It means for users to be able to reach that application, they just need to type 192.168.1.2 column what 2020. This will work fine. The users will be able to see the application running here. But for pod, right, the users cannot do this. They can't do 10.244.0.2 column 8080. The users will not be able to do this at all. It is not going to work. But instead, there should be some form of proxy that this service, right, would now create a pod, would create a port on this server. Where is going to get this port from? I'm going to explain. So it's going to create a port on this particular server. The service is going to expose this port so that when a user now wants to call this particular application, they will call, because of this node port that we have here, they will call 192.168.1.2. They will not call port 8080, but instead they will call this port 3008. Do you understand? So the person that asks the question of how to be able to expose the port internally, this is where the concept comes in, which I'm going to just quickly run like a sample demo right now. So let's go ahead and create a node port. So again, we start as usual with our API version. I'll be very fast because of our time. We start our API version and call it v1. Sorry. Okay. Okay. So let me just remove all of the, should I remove it? Let me just leave it. Our kind is, so my intelligence is not working because of this other stuff that I have here. So I can use these 3 dash to, demarcate different resources. So API version is v1. My kind is what? Service. Again, metadata, I'll be very fast there. Let's name the service my service, or name it DAPO application service. Application service this way, right? Define the spec. The spec is type of what? So this is where you now specify the type. I want to specify a type node port. Then the ports, I'm going to explain these bits shortly. The ports. So let me just type this. Target ports. I'll explain these bits. Let me just, because of the time, node ports. Let me say 3,000. And it's then define, I think we select top, yep, and up to, okay, good. Now, how do you define a service? Remember, we start with the API version. The kind is not pod, the kind is not replica set, the kind is not deployment, the kind is service. The metadata is just the name of the service. Remember, this service is for us to be able to log into this particular application that we just deployed. The type is what? Node port. I can either change this to node port or what? Cluster IP. Cluster IP this way. But cluster IP is just what? Intra. We want to be able to connect from outside, so we'll change it to node
what are the
ports.
difference?
Sorry? What are what?
What's the difference? The difference between node port and cluster IP.
But I just explained. I explained the difference. I said node pod is to be able to allow you to connect to the services by defining a port on the server itself. So externally, you should be able to connect to this pod by the time you create the node port, which I'm going to illustrate here. Why cluster IP is just for what? Within the cluster communication. So this is just within the cluster communication. Why node port is from outside. So meaning you are attaching an arbitrary port to this server so that anybody that now wants to call this particular application, they will call the IP address of the server and these ports here that have been defined. And I'm going to tell you how this port came about. So let us go ahead and quickly do that. So the spec is node ports, right? The ports that is here now. Now this is where it becomes interesting. There's ports, target ports, and node ports. What are the differences? The port here is the port of this particular service, because this service is also going to have its own ports. But to keep it simple, just assign the same port that you have for the service, the same port that you have for the application, assign it to the same service itself. So it's going to be something like this. It means the port that will be here, port 8080. This service is also going to have its own port 8080. And then the node port will have its own ports. So what are now the differences? The differences is the port is the port of the service. So this is the service port. Target port, just as the name implies, is the port of the target application. Very important. That's why it's target port. Where are you targeting? I am targeting this particular pod that is running the application that has been exposed on what port 8080. That is what this target port is. Why the node port? Now, by default, by the time you define a node port, Kubernetes assigns node ports between ports 30,000 to 32,700 and something. I have to look for that number. So the port that's going to be assigned here, right, is usually 30,000 to port 32,700 and I think 60 something. If you don't specify node ports here, Kubernetes is going to use any port within that range. So if you specify it, fine and good, but it must be within that range. If you don't specify it, Kubernetes is just going to use anyone within that particular range. So let's say we do not apply it, and then we just apply the port and the target port. Now, by the time you deploy this service, you're not telling the service that what pod should I expose traffic to? That is where the concept of your selector now comes in. You now go and pick the label. You can now see the function of the label that we have here within the deployment. You now pick the same label and apply it here. It's as simple as that. So let us deploy it. So we just copy this. Go to the Kubernetes cluster. Let me clear the screen. And nano, let's say svc.yaml. So I'm going to create this, paste it here. So it is expected that by the time we deploy this, right, we would see the node port that Kubernetes has actually used automatically. And we should also be able to access this particular application by calling the IP address of this server, and then that port, and then the node port that will be defined to us automatically. So let us save this. Right, so K apply -F and apply this. Okay, so it's saying that something is invalid. I think it has to do with the spelling. So I think I spelled node port wrong. So I'll just copy this. And okay, it's correct. So where are we missing it? Let's see.
I think the N should be capital letter.
Okay, yes, the N should be capital letter. Thank you. So there's the typo here, so I'll just replace it with this. And we'll just edit what we have here. So you can see the reason why I talked about documentation, because I just typed this up on top of my head because of time. So by the time we save this, press yes, and do a k apply again. So you can see that the service has created. So if you do k get service or k get SVC, you would see the port. So what do we have here? DACO application service, the node port. So it's telling me that the type is what? Node port. What is the port that has been exposed? 32,148. So this is the port that I'm going to use to access that particular application. So let us test the application and see if it will give us anything. First and foremost, this is the IP, this is the port. So this is the port here. So let us get the IP address of this server. 10.34.42. So it is expected that when we do this, we should see something. So I will just call this from a sandbox environment. Okay, so you can see the application. Can you guys remember this Golang application that we wrote?
Yes, yes.
So you can see it here. So even if I should come here and let me clear my screen and do a k get pod, look at what is happening. If I do a k delete pod and I'm deleting this, right? So let me just bring up this. If I should press enter this way, it doesn't affect the application because we have other replicas that are running. So in fact, let me even see if I can k delete. I don't know if I can delete multiple pods at the same time. Can you see? I've deleted 2. So let's go back to see if it's going to affect. Can you see? It is not affecting it because we still have other guys, k get pod, that have been created automatically. So let us scale that particular application to 1, right? And see what will happen. So k ls, what was the YAML file that we will use? Deployments. So nano, and let's change these replicas to 2. So we'll save this and k apply. I want to apply this. Guess what this guy is going to be doing? It's going to do a what? It's going to scale it down. K apply this. Sorry, minus F. Minus F. So k get pod. 2 is running. If you go back and refresh this application, it's still running. So that is where the concept of high availability comes into play. So this node port that is here, k gets SVC, right? I am not calling the cluster IP. This node port enables this application to be accessible by calling the IP address of the server itself, and then the port that has been created automatically for me. So if I do this, k get SVC and delete the service, delete SVC, if I should delete this and come back here, it shouldn't work because the service is down. Okay, let's see. Okay, let me see. Okay, let's refresh again and see. Let me do it on another browser. I think this thing is caching. new accumulator mode. So it shouldn't go. The initial one is because maybe it's caching. That's why it shouldn't even go because I'll be able to delete the service. So if I should run this new accumulator, it won't go. So let us deploy the service again. Okay, where is that service? K apply ls k apply -f. Let's just check the port that has been given to a k get svc. You can see that this is another port. Remember that first port was what? 32148, but now is what? 30665. So if we should come here, we should come back to the server and type this. It should go. And I should type, let's say, shown. Of course, application is working. So that brings us to the end of the class. Although we have another one last bit that we need to talk about, though, but maybe I will just allow Nuruddin during this class to just talk about the resource limit, the resource and the pod limits. Very, very important. So as a DevOps practitioner, what you have here let me clear the screen again. K get pod. If users are actually making use of this particular application and then you do not configure what we call pod requests and pod limits, right? This particular application can make use of the entire CPU of the system of this particular node, and it can starve other resources. That's why it is important to configure requests and limits. So I won't talk about that. I will just allow Nuruddin during our next Kubernetes class. Nuruddin will just talk about that. All right, so that brings us to the end of the class. Any question? So I will just round up.
Well done, Dapo.
Yeah, sir. So
please, one after the other, please. Please, one after the other, Emmanuel.
Can I talk?
Yes, please go ahead.
Can you just help us to share the materials on how to install the Kubernetes, which is a production Kubernetes?